Okay, here we are again. Once again, boys and girls, this is assignment 9D of hypothesis testing. And really kind of like this first example because it's pretty close to an actual real study besides, information where they just blatantly tell you these things. This is similar to how the real world would work, and figuring out some of this hypothesis testing. So what we have here is we have a sample. Okay, we have a sample. And so right now, the important information that we have is this. We know that the average is supposed to be 30. Right now, I don't know what my sample average is. Also, note that they didn't give you a standard deviation to begin. So if I do, and when I do find a standard deviation, it's coming from the sample itself. So this is going to be an S, not a sigma, because this is a sample. This isn't all of the delivery times ever. This is just a sampling. So this is going to be an S. But again, they don't straight up tell you what it is. The sample size, I can figure that out. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's 10. But again, that came from our sampling. And then we have to have a 5% level of significance to see if it is less than 30 minutes. All right, so how do I get that X bar and how do I get that S? Well, the calculator is where I want to look. All right, so we're going to find a sample average and a sample standard deviation. So I go to that stat screen, I enter my list, and again, I want to go to calc, which is that F2 button, and 1var, the F1 button. All right, so from here, I am getting the information that I need. Okay, the X bar, the average is 28.4, and that's right there at the top of that. Now, my calculator looks a little bit different than your calculator, but they do give you an S. An S on your calculator, it should be denoted as, I think it's like SX or something like that. And that is your sample standard deviation. Okay, so this is a sample, this is where we're getting it from. And so our sample standard deviation should be 2.2211. Okay, it should be the one right above the N. So do it on your calculator, and that SX is the sample standard deviation. That's the S. Okay, but from there, we are literally constructing our own hypothesis. Okay, we're our own problem. So here we go. We need the null hypothesis, and that's what the average is. Right now it's 30. And so we stick with 30, and what are we trying to say? Oh, it's now is less than 30. That's what we're trying to say. Do we have enough evidence to say it? I don't know. Let's figure it out. Okay, the level of significance is 5%. And this is a left tail because the arrow is pointing to the left. Okay, because this is an S, this is going to be a student's T. Let me try that one more time. A student's T. Again, put the top and the bottom in their own unique parentheses, and you can use your calculator just fine. Don't worry about the negative. Don't worry about the negative, just look it up as a normal number. If it's a z, you'll always want to look it up as a negative. As a t, always think of the number as being a positive. All right, so here we're going to be constructing our p-value. And this is built upon a t of negative 2.2780 and a degree of freedom of, and again, this is n minus 1. So if n is 10, my degree of freedom is 9. Okay, so I look up that t-value on my t table, 2.2780. 2.2780. 2.2780 with a degree of freedom of 9. It's negative, but again, look it up as positive. So 9, I'm looking for 2.2780. 2.27 would fall right in between those two numbers right there, 2.27. So that's in between 2.262 and 2.821. So notice how 2.27 is in between those two numbers, which have corresponding p-values of 0.02, I'm sorry, I'm looking up from here. So they have corresponding p-values of 0.025 and 0.010. Okay, those are our p-values. Okay, here I have an this is a left tail with an alpha of 5%. So left tail, that means the rejection zone is on the left. This is our alpha, which is again 5%. 0.05. And now, again, regardless of which p-value I accept, is if I'm even accepting the largest, 0.025, even the biggest of the two is still smaller than the alpha. And again, I usually report the one that is closer, and so the closer of the two is 0.025. So in the best case scenario, the p-value is still smaller. So now I go to the results and I kind of summarize that. So the p-value is less than the alpha. That means I reject H naught, accept H1. All right, so again, as a reminder of what the heck I'm talking about, H naught says that the average is equal to 30. And the alternate is saying that the average is less than 30. So again, I'm just going to interpret those symbols. So I reject H naught, accept H1. We reject the average is equal to 30. So we reject the average is equal to 30 and accept the average is less than 30. So we reject that the average delivery time is equal to 30 and accept that the average is less than 30. real quickly, those middle symbols. This is equal to. This is less than. This is greater than. This one is not equal to. Okay, this coffee machine problem again. All right, let's see here. So we see that the average is supposed to be 7 ounces. The sample is 7.3. Now, notice how they say 8 cups of coffee have an average of this and a standard deviation of that. So the question is this a sigma or is this an S? That's the true question, because I need to know how to proceed with this problem. And notice that 8 cups of coffee is a sample. So whatever this 8 cups of coffee is telling you, it's a sample, whatever. So if they tell you an average, that means it's a sample average. If they tell you a standard deviation, that means it's a sample standard deviation. So if a sample is telling you information, it's giving you sample stuff. That means X bars and S's. Okay? Again, is in the contrary, a population average is mu. And a standard deviation is sigma. Right, so here, because it's coming from sampling, we're getting an X bar and an S. So back to my question is this a sigma or an S? This one, because it's coming from the 8 cups of coffee, this is an S. So the sample standard deviation is 0.5. Sample size was 8 cups of coffee, and level of significance is 5%. Okay. No, and what's the question? I'm sorry, what's the question? Is it different from, so that means is not equal to. That means is not equal to. Okay, here we go. H naught says that the average is 7 ounces. Alternate hypothesis, we're trying to show that the average is not equal to 7 ounces. Level of significance is 5%. And this is a two-tail. I don't think we've done a two-tail using the T before. Okay, because this is an S, this is a student's T. Top and bottom in their own unique parentheses. What was this? A sample size of 8 cups of coffee? Yeah, so this degree of freedom is going to be 7. Okay, so I know that this is a two-tail, and I'll explain the difference here in just a moment. But let's go ahead and find where the heck this is. So degree of freedom of 7 with a t of 1.6971. So degree of freedom of 7, 1.6971 is going to fall right in between 1.617 and 1.895. 1.617, 1.895. So it's somewhere in between those two. Okay. Now, before we were dealing with one-tail areas, whether it be a left tail or a right tail. We've been dealing with one tail. This is a two-tail. And so when you have a Z and you get this p-value coming off of a Z, you have to multiply by 2. However, when it's a T and you get this p-value, it's on the table that you can look it up. You don't have to multiply by 2. They've already technically done it for you. All you have to do is look at the two-tail area when you're looking up your p-value. So you don't have to multiply by 2. They've technically already done it for you. All right, so 1.617, again, I look at the two-tail line because this is a two-tail test. So the only time that you actually multiply by 2, okay, again, is when it's a Z and it's a two-tail. That's the only time that you multiply the p-value by 2. Everything else, you don't. That's the only time that you physically have to do something special. Okay, so 0.150 and 0.100. So that's your p-value. It's a little bit more steep. Okay, this is a right tail. No, excuse me, this is a two-tail, I'm sorry. This is a two-tail. These are alphas. And this has a p-value of 0.150, 0.100. Both of them are larger than the alpha. So either one is going to fall larger than the alpha. And so I'll give the smaller of the two just for argument's sake. And so the smallest it could be is 0.100, and even the smallest is larger than the alpha. So I see that my p-value is larger than my alpha, and these do not reject H0. That means we do not have enough evidence to say H1. We do not have enough evidence to say H1. H1 says that the average is not equal to, what were we even talking about? Oh, coffee, 7 ounces. Okay, that's what H1. So we do not have enough evidence to say H1. So the average is not equal to 7.0. Okay, since this is the first time that I'm mentioning the average, I have to add context. Okay, so the average is not equal to 7.0 ounces. So again, all I'm doing is I'm interpreting the symbol. The average is not equal to 7.0 ounces. So that's a two-tail.